Hello, in this video we're going to be using upper and lower bounds in calculations. So the objective here is to use error intervals to find maximum and minimum possible values in calculations. So here's an example. A rectangle has a length of 8 centimetres to the nearest centimetre and a width of 5 centimetres to the nearest centimetre. So we need to find the upper and lower bounds for the area. So the first thing I'm going to do with this is I'm going to write down the bounds of the lengths in the question. So we have 8 centimetres, which is to the nearest centimetre. So 8 centimetres is between 7.5 centimetres and 8.5 centimetres. And 5 centimetres is between 4.5 centimetres and 5.5 centimetres. So we want to find the upper and lower bounds for the area. So the area of a rectangle is length times width. So to find the lower bound, I'm going to do the lower bound of the length times the lower bound of the width. So it's going to be 7.5 times 4.5, and that is going to be 33.75. And the units for that are centimetres squared. So now to find the upper bound, I'm going to do the upper bound of the length times the upper bound of the width. So the upper bound is going to be the upper bound of the length times the upper bound of the width. So that's going to be 8.5 times 5.5. So that is going to be 46.75 centimetres squared. So the smallest possible value that the area could be is 33.75 squared centimetres, and the largest value that the area could be is 46.75 squared centimetres. So now we want to find the upper and lower bounds for the perimeter. So for a rectangle, to find the perimeter, you add up all of the sides. So a rectangle has 4 sides. So if we want to find the lower bounds, we're going to add up all of the smaller numbers. So we're going to do 7.5 plus 4.5 plus another 7.5 plus another 4.5. So if we add up those numbers, I'm doing 15 plus 9, so that's going to be 24 centimetres. So now if I want to find the upper bounds, I'm going to use all of the larger numbers. So in this case, I'm doing 8.5, 5.5, 8.5 again, and 5.5 again. So if I do 8.5 plus 8.5, that's 17, and 17 plus 11 is 28. So the perimeter of this one is going to be 28 centimetres. So that tells us that the upper bound for the perimeter is 28, and the lower bound for the perimeter is 24. So this question here, we have a circle with a radius of 5.1 centimetres to 1 decimal place. We need to find the upper bound for the area. So the first thing I'm going to do is I'm going to write out the bounds for 5.1. So 5.1 is going to be between 5.05 and 5.15. And we want to find the upper bound for the area. So the area of a circle is given by pi r squared. So if we want to find the upper bound, we're going to do pi times the upper bound of the radius, which is 5.15 squared. So pi times 5.15 squared, that's going to be 83.3. So now we want to find the lower bound for the circumference. So the circumference is given by 2 pi r. So if I want the lower bound, I'm going to use the lower bound for the radius. So it's going to be 2 pi times 5.05, and that's going to be 31.7. So the area that's given in squared centimetres, and the lower bound for the circumference is 31.7 centimetres. Here's another example. So this time, speed is distance divided by time. So the distance is 120 kilometres to the nearest kilometre, and the time is 2.1 hours, the nearest 0.1 hours. So I'm going to start off by writing the bounds. So 120, that's to the nearest kilometre. So it's between 119.5 and 120.5. And 2.1 is between 2.05 and 2.15. So this time we want to find the upper and lower bounds for the speed. So if I start off by trying to find the lower bound, to find the smallest possible value, a lot of people would think that we divide the smaller number by the smaller number. But when we're dividing, to get a smaller number, we actually divide a smaller number by a bigger number. Because if you divide by a bigger number, you get a smaller number. So we're going to do the lower bound for the distance divided by the upper bound for the time. So the lower bound of the distance is 119.5. and the upper bound for the time is 2.15. So I'm going to do 119.5 divided by 2.15, and that's going to be 55.6. And now to find the upper bound, to get the biggest possible number when we're dividing, we're going to divide the bigger number by the smaller number. So this time we're going to do the upper bound divided by the lower bound. So that is going to be 120.5 divided by 2.05, and that is going to be 58.8. Here's another example. So a rod has a length of 12.4 centimetres to 1 decimal place, and another rod has a length of 7.8 centimetres to 2 significant figures. So I'm going to start off, as always, by writing the bounds. So 12.4 is between 12.35 and 12.45, and 7.8 is between 7.75 and 7.85. So if I'm trying to find the upper bound for the difference, so the difference, what we're going to do is subtract them. So we're trying to do 12.4 minus 7.8, and we're trying to find the upper and lower bounds of that calculation. So if I want to find the lower bound to get the smallest possible number, I'm going to do the smaller number minus the bigger number. So I'm going to do the lower bound minus the upper bound. So that's going to be 12.35 minus 7.85. So that is 4.5. And then to get the upper bound, I'm going to minus the smaller number from the bigger number. So that's going to be the upper bound minus the lower bound. So in this case, it's going to be 12.45 minus 7.75. So that's going to be 4.7. So the biggest possible difference between them is 4.7, and the smallest possible difference between them is 4.5. Here is a quick fire practice question on this topic. Pause the video, have a go at this one, and I'll reveal the answer in a moment. Okay, so well done if you managed to have a go at this. So this is the answer. So the maximum is 16 and the minimum is 14. So that's everything for this video. So thank you so much for watching, and I'll see you again in another video. Bye!